The last two questions on the review are honors content, so I'm covering them just in this separate video. These two relate to the special case triangles. So again, you can use SOHCAHTOA on these if you want to just find x or y at the same or at one at a time, or you can recognize it's a special case triangle. So remember we talked about a 45-45 triangle is an isosceles triangle. So we have a 45-45-90. That means that these two legs are always the same length, right? It's half of a square. And then the diagonal, if you were to use the Pythagorean theorem, is always just root 2 bigger. Okay, and then the other one we talked about came from half of an equilateral triangle. This one was a 30-60-90, so there was always a short leg across from the 30, and that was the one we always referred to. The hypotenuse was always double that, because again it comes from an equilateral triangle where the base is half the bottom, and the hypotenuse would then be double that. The long leg then, the one that is opposite of the 60 degree, is always root 3 bigger than the short leg. So again, we refer everything to the short leg. So using those two, we could look at these last two examples, and here we have a 45-45. Again, we're not given that, but we know that that's going to be a 45-45-90. Here's our two legs, so we know the legs have to be the same length, so y must be equal to 10. And then again, you can either use the Pythagorean theorem, or we recognize as a special case triangle, the hypotenuse will just be root 2 bigger. So we know that y is 10, x is 10 square root 2. Looking at 23, same idea. If we're looking at this piece right here, then we know that this is the hypotenuse, and the short leg is always half of the hypotenuse. So we're looking at something that would be like 3, and then this is root 3 bigger, so this would be 3 square root 3, so we can work through that.